Hey, top of your life math industry, and we are going to take a look at forces at an angle. And we've been using a lot of physics to understand the natural forces of a cube, even when it stays still, but also when we push it along. But here's what's going to happen. So, if we know that there are 4 natural forces on a cube, there's going to be the F of G, the gravity, the F of M, normal force, F of F, friction force, and F of A, PP, force being applied on the object. But the thing is, imagine you have a block. But the problem is, instead of pushing in the middle, you're pushing on it up here, just like as you'd be pushing on top of a chair. So, to put this into perspective, instead of doing it this way, you're doing it this way. Just like you're pushing a school chair in your classroom, your physics classroom. But that's going to kind of mess up the physics. How are we going to do that? So right over here, we have a 5 kilogram block of plastic. Your force being applied is wanting to go this way. But the problem is, you are not pushing on the side. You are pushing diagonally, which is going to somehow make a right triangle. So if this is your right triangle right here, not only you're pushing the block to the left, but you're also pushing some downforce on the block too. Let's say your arm is 20 degrees from the top, and your force pushing down on the block this way is going to be 35.32 newtons. Let's see what happens. So you're trying to push a block to the left with 35.32 newtons at a 20 degree angle. How are we going to solve that problem? Well, since we made a right triangle right there, if we can find what that thing right there is, if we can find what this side here is for the force being applied to the left horizontally, then we can definitely find how much force is applied on that block horizontally. What we have to do is use trigonometry. So remember, from trigonometry, we like to use the sine, which is opposite divided by hypotenuse, the cosine, adjacent divided by hypotenuse, and the tangent, the opposite divided by the adjacent. So, according to the triangle over here, we have a hypotenuse. The opposite is going to be the opposite of the angle. So that's going to be right here, the opposite. Now, that right there has to be the A, the adjacent. So here's what's going to happen. What of the 3 contain a hypotenuse, an angle, and we need to find the adjacent? Yes, we have to do the cosine. So here's what's going to happen. The cosine of 20 is going to be equal to A, or let's say X, divide that by 35.32 newtons. So when we find the cosine of 20, but then we have x divided by 35.32, we're going to get an answer of x equals 37.59 newtons. So that number right there is explaining that even though you have a downforce of 35.32 newtons at a 20 degree angle, your x is going to be 37.59 newtons to the left, horizontally. But hey, we could also find the direct downforce as if you were pulling the block down or pushing it down. You know that opposite angle or that opposite side of the triangle? We're going to calculate how much force is applied if you continue what you're doing with that block, but is trying to push it down. So, yes, we have to use that triangle again. And yes, we seriously have to use SOHCAHTOA to solve it out. So we're trying to find the opposite one. What are we going to do? Well, if we try to find the sine, that can work. So here's what's going to happen. The sine of 20 degrees is going to equal the opposite divided by the hypotenuse, right? Yeah. So that is going to tell you that if you have the sine of 20 degrees, and we have to equal that by we don't know what our opposite is, because we are trying to find what that is in the triangle. We do know what our hypotenuse is, 35.32 newtons. So we have to divide by 35.32. When you do that, you're going to get an answer of x is going to equal 13.68. So that is telling you 13.68 newtons is the amount of force and pressure that you're pushing to the ground, or vertically on the ground. You're pushing 35.32 newtons diagonally at a 20-degree angle, 37.59 newtons at a horizontal line to the left, and 13.68 newtons down force. But what about the acceleration? If you're doing all that so-called force and applying that force on that 5-kilogram block of plastic, how fast is that block going to go? Or how fast are you going to push on that block that's going to make that block go? Well, here is where it comes easy. We know that when you always push on something, you get F of net force is going to equal MA. The net force has to be somehow a lot bigger and a lot greater than the friction in order for it to actually move. So here's what's going to happen. Our F net horizontally is going to be 37.59. That is the amount of force going this way, horizontally. But we have to equal that by 5 kilograms. That is going to be our mass of the plastic block right there, is going to equal A, or 5 times our A, which is our acceleration. So we get 37.59 is going to equal 5A. Divide that by 5. Divide this side by 5. And our acceleration, how fast you're moving that block using force, is going to be A equals 6.52 meters per second squared. So doing all that force and the information on that triangle, you will be able to push that block at an acceleration of 6.52 meters per second squared. And that is how we use the forces at an angle. Not only you change the direction of where you are pushing, but also not only you're pushing the block to the left, you're pushing it at an angle, and you're also having down force on it. I hope this video has helped you understand forces at an angle. Thank you for watching Top Analyze Math Industry. Like and subscribe.